Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to another edition of the online class. In our last class, we talked about types of reaction, where we discussed the combination reaction, the thermal dissociation reaction, the displacement reaction, the thermal dissociation, reversible reaction, combination reaction, and then the catalytic reaction. Today, we are going to be looking at the oxidation reduction reaction, which is also known as redox reaction. The redox is gotten from the first three letters of reduction and the OS. They come together to form the redox reaction. Now, in this redox reaction, it involves two processes, that is oxidation and reduction. These two processes take place, or we say it occurs simultaneously in the same reaction. Now, in this reaction, one of the reactants will be oxidized or is oxidized, while the other is reduced. Now, we have different definitions for this oxidation reduction reaction, in which we are going to be looking at now. The first one is in terms of electron transfer, which is also known as the modern definition. Oxidation is simply the loss of an electron. When you lose an electron, you become oxidized. And then reduction, as you gain an electron, you become reduced. Now, let's look at these two reactions here now. If you look at the first one, I said oxidation. Copper in a free state here has oxidation is 0. But after it has lost 2 electrons, it becomes copper 2. That means as it loses electron, copper becomes oxidized from 0 to +2. That is that. And if you look at this second one, iron 2. When iron 2 gains 2 electrons, it becomes iron 0. So as you gain electron, you undergo reduction, while as you lose electron, you undergo oxidation. So that is the definition in terms of electron transfer. Now let's look at the second one in terms of oxidation number. Oxidation is defined as the increase in oxidation number, while reduction is decrease in oxidation number. Now let's look at it from this example of the reaction of the redox reaction given below here. If you look at the arrow here, from iron 3 to iron 2 is reduction, due to the fact that the oxidation number has changed from +3 to +2. And if you look at that of the iodine, is oxidation, because iron in a -1 state has changed to iron 0, and that is that it has what? Undergo reduction. It has undergo reduction. Now what happens to iron 3 here is that iron 3 has accepted 1 electron, while the iodine has given out 1 electron. So that is that on in terms of oxidation number. Now let's look at the third one in terms of oxygen and hydrogen. We say oxidation is the addition of oxygen or removal of hydrogen, while reduction is the addition of hydrogen or the removal of oxygen. If you look at them, they are vice versa. Now, if you look at this particular redox reaction here, you will see copper in +2 states. Copper here has lose what? Lose an oxygen. That is, if you look at this arrow here, from this place to this place, that means there is a removal of oxygen there. which is reduction. And if you look at hydrogen here to that of, if you look at the arrow to that of water, to water, hydrogen then convert to water, it means that hydrogen has accept oxygen. And if you accept oxygen, that is addition of oxygen, you undergo oxidation. While in copper, removal of oxygen, it undergo reduction. So that is that. Now, let's look at the definition in terms of electronegative and electropositive elements. We all know what are the electronegative elements. Majorly they are non-metals, and the electropositive elements, majorly they are metals. Now, let's look at the definition. Oxidation is the addition of electronegative elements or removal of electropositive elements, while reduction is what? Is the removal of electronegative elements or addition of electropositive elements. Now, let's look at this redox reaction here. If you look at from calcium to calcium chloride, that means it is what? It is oxidation, because there is addition of electronegative elements, which is chlorine. And if you look at from chlorine to the same calcium chloride, you will see that that is reduction, because what? The chlorine has accepted electropositive element, that is addition of electropositive element. So from chlorine to calcium chloride is reduction, addition of electropositive element, while from calcium to calcium chloride is what? Is the addition of electronegative element, that is calcium chloride. So that is that. Now let's continue. That is all about the definition of oxidation and reduction in terms of in terms of electronegative elements, oxidation number, electron transfer, and so on like that. That is the end. So let's look at the electronegative and then the positive electronegative elements. See, the electronegativity decreases as you move from chlorine to phosphorus, and here the electropositive element, that is the metals, as you go, it decreases, that is from potassium to mercury. There you see it, see the arrow, it decreases like that. And also the electronegative element, it decreases as you go from fluorine to phosphorus, it decreases. So the next thing that we are going to be looking at now is oxidation number. That is what we are going to be looking at next. Now, what is oxidation number? Oxidation number is the apparent charge of an atom in a molecule or ion. That is, the charge on a molecule or ion is known as oxidation number. Now, let's look at the rules guiding on how to assign oxidation number. The first one says all elements in a free uncombined state, have oxidation number of 0. That means potassium. If potassium, if you look at it, potassium, sodium, in a free state, all of them like that, they have oxidation number of 0. That means when we say they are in free state, they have not accepted electron and they have not given out electron. Now, rule number 2 says that the oxidation number of simple ion is the same as that of the charge carried by that ion. Now, I've given some examples here. If you look at calcium here, is carrying a charge of +2, so the oxidation number is +2. the sodium is +1, oxidation number is +1, and so on like that. If you look at oxygen, there is -2, and so the oxidation number of oxygen there is -2. We've known the reason why they are plus and why they are minus. So that is what rule number 2 is saying. That is what rule number 2 is saying. Now let's look at rule number 3 now. Rule number 3 says that the algebraic sum of the oxidation number of all elements in a compound ion is equal to the charge carried by that ion. Now if you look at this, they are all radicals and they are carrying charge. All of them like that. If you look at this, tetraoxomanganate 7 is carrying a charge of -1 here. So ammonium ion also +1. Carbonate, triazocarbonate 4, tetraoxosulfate C is carrying a -2, and so on like that. So the algebraic sum of the algebraic sum of the oxidation number of elements in a compound ion, they are all compound ion, is equal to the charge carried by that particular ion. Now rule number 4. Rule number 4 says that the sum of all oxidation number of elements in a compound is 0. If you look at, I've given examples there. Sodium chloride, the oxidation number is 0. Potassium triazochlorate 5 is also 0. Potassium tetraoxomanganate 7 is 0, and so on like that. All of them, because they are compound, they have oxidation number of 0. Now rule number 5. Oxidation number of hydrogen in combined state is always +1, except when they are in combination with metals, that is metallic hydride. They carry -1. Number 6, oxidation number of oxygen in combined state is always -2, as we all know, because oxygen will accept 2 electrons, except in the peroxide where they are -1. Oxidation number of alkali metals, we all know alkali metal, that is the group 1 element in combined state. The oxidation number of alkali metal in combined state is always +1. Is always +1. Number 8 says that oxidation number of alkaline earth metal, that is the group 2 element in combined state, is always +2. And then oxidation number of aluminium in combined state, which is in group 3, is +3. So let's go on. So that is that for the rules. Now let's find some oxidation. Let's find the oxidation number of some compound now in an element. If you look at, say, example, find the oxidation number of the underlying element and state their IUPAC name, that is their IUPAC name. Now number 1, this is potassium dichromate 6. If you look at it there, the chromium is underlined, so that is the one they say we should look for the oxidation number. Now if you look at the calculation here, potassium is, we say, is always +1 because it's a group 1 element, but we have 2 there, +1 times 2. Then chromium is 2 there, but that is the one we are looking for. That is why we say 2x, that is the unknown. Then plus oxygen is -2, as we have known from the rule, but oxygen there is 7, -2 times 7 like that. So if you go like that, we have +2 plus 2s minus 14 is equals to 0. Plus 2s is equals to 14 minus 2. That means if the 2 is going to the other side. Now 2s is equals to 12. And then you divide both sides by 2. You have s is equals to 6. That means the oxidation number of chromium there is 6. And the name is potassium heptaoxo dichromate 6. Potassium heptaozo dichromate 6. Now moving to the second one. If you look at the second one, is the N that is underlined. So we have potassium there plus 1. Then the N nitrogen is what we are looking for, the oxidation number, plus X, plus, then we have oxygen there, 2 oxygen, minus 2 times 2. Then we have plus 1 plus S minus 4. And then S is minus 3. S is equals to 3. And that is why we have the name there, potassium diozo. Diozo means we have 2 oxygen there. Potassium diozo nitrate 3. Because nitrogen there has oxidation number of plus 3. Now, the third one there is the chromium, is the chlorine that is underlined there. So we have 1 potassium plus chlorine, which is 1 plus X is the one we are looking for, plus minus 2. Oxygen is minus 2 there times 3. So we have plus 1 plus S minus 6 is equals to 0. We have S minus 5 is equals to 0, and S is equals to 5. So we have the name there, potassium triazo. We have 3 there, 3 oxygen. So potassium tri means 3, triazo chlorate 5. That means chlorine in plus 5 state. The next one there is this, is the sulfur that is underlined. So we have X there, which is the unknown, which is sulfur, plus minus 2. Oxygen is minus 2, but we have 3 oxygen there. So minus 2 times 3 is equals to, if you remember our law, all of them are carrying a minus, all of them are carrying what? They are carrying minus 2. If you still remember under our rules and regulations there, says that if you remember our rules and regulations there, where it says that, sorry, let me come again there. We have sulfur there, which is the one that is unknown, and then we have oxygen there. Oxygen is 3. So if you look at it, S plus 3 minus 2 times minus 2, which is the oxidation number of oxygen, minus 2 because we have 3 there, is equals to minus 2. If you remember, we said the algebraic sum of the oxidation number of all elements in a compound ion is equals to the charge carried by that ion. You still remember that, and that is why this is minus 2. So we have there S minus 6 is equals to minus 2. S is equals to minus 2 plus 6, if 6 is going to the other side. At the end of the day, we have S is equals to 4. So we have trioxo, 3 oxygen there, sulfate 4, sulfur in plus 4 state. Now the last one there is still the sulfur that is being underlined there. There ion, we have ion plus 2 plus X plus minus 2 times 4 because we have 4 oxygen there. So we have plus 2 plus S minus 8 is equals to 0. And S minus 6 is equals to 0. S is equals to 6. So we have there ion 2, tetraozo 4 oxygen, tetra means 4. 4 tetraozo sulfate 4, sulfur in plus 4 state. Sulfur in plus 4 state. So ion 2 tetraozo sulfate. Sorry. Sulfur in plus 6 state, not plus 4. Let me repeat myself. Sulfur in plus 6 state there. So we have there, the IUPAC name is ion 2 tetraozo sulfate 6. I repeat, ion 2 tetraozo sulfate 6, sulfur in plus 6 state. Now, this is your assignment. 1. Find the oxidation number of the underlying elements there and state their IUPAC name. Sorry, the line did not show there. Here we are looking for oxidation number of sulfur there, and here here we are looking for oxidation number of phosphorus. This place we are looking for that of sulfur, and this one we are looking for that of manganese. So sorry, it was not underlined there. So this is where we are going to stop for this class today. Until we meet inshallah in the next class, I will still employ you as you are at home. Please, let's study of our notes. Let's look at all our assignments, including our notes. Allah will assist us. Assalamu alaikum wa rahmatullahi